we're going to talk about OpenAPI in the context of Clojure in particular. And yeah, so my name is Max Penet. Thank you for having me tonight. It's a pleasure. It's a great meetup. Watch many of your videos. I apologize in advance because my voice is a bit broken. I had quite a nasty flu these past few days. And yeah, I hope you don't mind. Just so you can find me on these various websites. And yeah. So who I am? I'm based in Geneva, in Switzerland, but I've lived in a few different places. I actually just got back in Switzerland. I'm from here, but I just spent 10 years in Sweden. I've been using Clojure for quite a while now. So as my job also since 2010, basically, which is very early, I realize. But yeah, I got lucky back in the days, finding the right people, the right time, and the right tools. And I got to work with it from this year. And I've been doing software engineering, quite a while before that. I've worked for various startups during this time, done some consulting, worked for regular companies as well. And currently I'm working at Exoscale. It's basically a cloud hosting platform, so you can think of it as an equivalent of, a competitor to AWS or GCP, but more moderate size, let's say. But it's a very good product, and yeah, have a look at it if you want. I've been doing quite a fairly substantial amount of open source during these years, mostly around Clojure, but some other things. I've tried to be involved in the community also in various ways. So I've been present in IRC, Slack, and all these things for a long time. And I have been also a board member of Clojurists Together and a member also nowadays. And yeah, I also encourage you to look at the website if you want to contribute. It's also a great thing to follow. So what is the context of the discussion we're going to have tonight? So my employer, like I said, is Exoscale. So it's a medium to large size company. I mean, we are around 100 engineers, I would say, probably a bit more even nowadays, and it keeps growing. So while back in the days, it used to be very, very much Clojure centric. I mean, I would say 80% of the code written at Clojure at Exoscale used to be Clojure. It's no longer 100% true, but it's still one of the major language there. But we have people doing Golang, we have people doing Python, there's some Rust services, there's a bit of everything nowadays. And with that comes a lot of tooling, a lot of services that gravitate around these tools, and a lot of people, which means a lot of opinions about, on how you should do things. So in the context of, well, basically OpenAPI, why did we look into that? Why did I look into that in particular? So when I joined the company, the CTO back then and a few other people started to work on this framework that was to be the foundation for the V2 of the public API and the internal services, which was meant to expose everything as OpenAPI or through OpenAPI. So they wanted to have something that was future-proof, consumable internally, but also exposable to customers, and from which we could generate tooling, basically. So, sorry, back in the days, there were like the obvious contenders already. So GraphQL was already there, and it was already a potential choice, which was ruled out mostly because of it's extremely expressive when it comes to querying, probably too much, and it can cause problems with that. Not really problems, but you have to deal with that complexity to not cause query explosion and this kind of thing. So they wanted something a bit simpler. So nowadays, and also even back then, there was already gRPC. So while gRPC is great to describe your services internally or to communicate between your services internally, is not the best fit, I would say, to expose your services to your end users. I mean, we do use gRPC on some of our services today, but it's not the default. And then OpenAPI. So OpenAPI, there's Pattern 3. I'm sorry, I'm going to mention that first. So I think there was Pattern 2 back then. I mean, one of the early versions, which is, if you don't know, it's a bit like GraphQL, but it's very much Clojure-centric. And it follows a bit the same philosophy as Datomic. where like the attributes are disconnected basically from entities, in the sense that an attribute can point to, can resolve to something by itself. It doesn't have to be part of a bag of things, like let's say a VM. But the problem with Patam, I mean, as much as I really like it, is that the tooling for it is not, it's not great, or it was not great back then. I mean, you would have to build a lot of things yourself, and that was not really our business. So we just chose OpenAPI. It was like the obvious choice. For various reasons. It was specified, fairly simple, fairly extendable, all generators for a lot of languages. So let's go. So yeah, that's what we chose. But today, I think we would still do the same choice. I mean, just like Clojure, it's an old thing, but I think it aged quite well. Overall, the people who work on OpenAPI took the right decisions over the years, in my opinion. So nowadays, we're at OpenAPI 3.1. So just to go back in time a bit, OpenAPI used to be called Swagger back in the days. But essentially, the name, they converged to OpenAPI a few years back. And they're at version 3.1 nowadays. It aligns also with JSON Schema, which is a different specification, which is at version 2020-12 nowadays. So yeah, OpenAPI is a superset, let's say, of JSON Schema. You can basically describe your schemas inside OpenAPI, I mean the shape of the things you want to describe with JSON Schema. It was not always the case. Back in the days, the earlier versions of OpenAPI had their own schema format, which was a weird subset of JSON Schema, but not quite the same, with a bunch of quirks that were not great to deal with if you are used to treat JSON Schema in particular. So how does it look like? I'm gonna just show you that. You probably know how it looks like, but a little recap. So typically a document, so that's a YAML version of a JSON schema, but the same in JSON would, just have a bit more brackets. So it starts like with a description of what the schema is, the version, bunch of metadata. But the most important part here, it also tells you where the servers are located to interact with the endpoints of that service, which is very nice. Also describe the routes, I mean the endpoints on that service, which they call path, which are basically URLs and the HTTP method to reach them, and a bunch of metadata about them, some of which we're going to talk more in detail a bit later. So if we just go a bit more in detail into the scheme, the path definitions, you can see here, some actually optional metadata like operation ID, but the parameters also, which is like the first time we actually see like a schema that describes the shape of what the parameters should conform to. And some pattern matching also on the status code for the responses, and the headers, the content type header, which should be application JSON in that case, which points then to another schema. And you can see other examples of that here. I mean, it's more or less the same. Another nice thing it comes with is all these UIs. And I mean, these are very old ones. I show it just for fun, but there are some very fancy ones nowadays, which looks much better, that are full of React stuff and that allow you to generate curl examples and all this kind of stuff. And I mean, it's very handy when it just comes for free, basically. And nowadays, it's really based on just standards all the way down. So OpenAPI itself is a standard. It depends on JSON schema, which is a standard. JSON schema integrates with like JSON pointers. With all kind of other specs that are related. So it's very easy to write basically libraries. Not very easy, but it's fairly it eases the work when you have to write code that deals with these things. And it's fairly widespread. If you look at probably, 50% of the sites you interact with, they will very likely have an OpenAPI specification around for them. But sometimes it's like their main API. I can think of Stripe, I can think of, even a bunch of the AI companies that are out there, they also use OpenAPI quite heavily. So like I said, it's multi-language. You have generators for like everything. So because it's been here for 14 years, people wrote generators and clients for pretty much everything. And yeah, that's quite, it's quite nice when you don't have to write this code yourself. It's still an evolving specification. So there's like a committee and there's a foundation. I mean, there are all these kind of, there's this structure behind OpenAPI and JSON Schema. And they actually steer the project quite well, I think. So they try not to add, unnecessary stuff to it. And so far, they've took the right decision, in my opinion, for a lot of things along the years. And they continue to do so. For instance, lately, they're talking about error formats and things that are a bit blurry in the specs. And so it's going in the right direction. And it is very expressive. So, so to recap, what we get in the schema, I mean, the broad lines is basically these. How to reach a service, the endpoints of that service, the details for the input-outputs for these endpoints, potentially descriptions of entities around these services like error shapes or other things like that, on the source for documentation. I'm sorry. Schemas, so they support a bit like the usual suspects, so scalars, collections, enums, properties, what we like to call maps, but also combinations of the above. So you can very easily express that a thing should be match this and that or not this, and so on and so forth. So it does match quite nicely the stuff we're used to with spec, Mali, and all these things. It also is also quite powerful nowadays when it comes to schema composition. So schema composition, in the sense you can declare pieces of your schema and reuse them in various places inside a schema, or even from other schemas, which we'll see later. The latest versions of the specs allow you also to basically define open or closed schemas. So you can say like basically that a map should be open to allow extra properties or not. And if it allows these extra properties, you can also go as far as specifying what should be allowed. Like you can broaden the scope of your validation basically nicely. So there's like you can have quite a lot of granularity when it comes to descripting this part. There's also dependent schemas nowadays. So you can say, okay, if the field this and the field that are present, maybe check that there's also these other fields present. I mean, you can basically have sub-schemas depending on the presence or not of some fields. So it's quite nice. And it's something, if you think about it, that's not really easily doable with Mali or specs outside of just writing an arbitrary predicate. So it's it's quite good, I think. Conditionals. Yeah, it even supports conditionals nowadays. So you can, I mean, it's not almost incomplete, but it's getting there. You can do if, then, else, constructs inside your schemas, which I never had to use, but it's there. I mean, you can end up doing that if you really want to. And ref and ID. So when I talked about compositions, they basically rely on these two things. So you can basically put an ID on a schema pretty much anywhere in your document, and then refer to it with the ref keyword in the current schema where you are, but potentially in other schemas, because the references can point to basically it's a URL, so you can an URL. So you can point to anchored links, so you can point to a relative link inside, in your server, or even to another server, which could contain this reference, with all the risks and the problems that it could cause. But you can put safeguards around that. But it's very powerful and it's very useful, especially when you're a company with this number of people and this number of services, and you don't want to define in 50 places the list of data centers that you can interact with, for instance. So like I said, it depends heavily on JSON schema. So have a look at this website. It's where they put most of their documentation, and they have quite succinct guides and examples that boil it down nicely and explains what you can do or not do. In the Clojure landscape, because we're here to talk about Clojure, but so far we didn't talk about it so much. So there are a few solutions that you can use today to generate OpenAPI services. The number one today is probably Rate It. So Rate It has, well, it supports a lot of stuff. So it's a routing library, but there are a lot of optional modules. One of them, forgot if it's like called Rate It Swagger or Rate It OpenAPI. But basically you can, inside your root definition, points to Mali schemas that then would cause an OpenAPI file to be generated and served, I think, through the routing library. And then Mali takes care of the validation. I mean, it's a nice solution. I mean, if you want to take things in this order. Then there is a library that I wrote a few years back called Pact, which, because we don't use Mali at Exoscale. We rely more on spec. And we wanted to be able to generate OpenAPI schemas from specs directly. So I wrote this library that basically does that. You pass a spec to one of the function in Pact and you get a JSON schema generated. And there are ways to extend the code to generate pretty much anything you would want. And that's a solution. You can build on this also to do something similar to what Rate It does, or compose it differently because there's no routing, there's no coercion, there's no, all this stuff has to be added separately through other libraries, some of which we actually open sourced also. There's Jinx from Juxt that was written a few years back, which is actually a quite nice implementation of a JSON schema validator / parser purely in Clojure. It works quite well, but there's one drawback is that it stayed frozen a bit in time. I think it supports up to draft 07 something. I don't remember the exact number, but it matches the version that was the latest back then, which is lagging a bit behind. And didn't want to take on maintaining it and upgrading it and all that. And there's Navi, a very recent library also, which takes a similar approach to the one I'm going to talk about later, which basically takes an OpenAPI file directly and generates middlewares, handlers that trigger validation from that directly. And it's written entirely in Clojure, so it doesn't rely on some large external dependency other than I think than the Swagger library for parsing schemas, because given that we have references and IDs, like I mentioned before, there are some tricky bits in expanding JSON OpenAPI documents because you have to be able to resolve all of these, and there are a bunch of rules that are a bit fiddly to deal with when it comes to that part in particular. But all these libraries, they take very different approaches if you think about it. I mean, mostly there are like two main ways of dealing with that. So if you look at Mali, or the thing we did with Pact, or I think JSON tools also back then. So things start with a proprietary DSL, whether it's Spec or Mali or something else at the bottom. Or also the library that we wrote back then, Blueprints, which predates Mali, uses another DSL even. That's basically you write hidden that then is transformed to OpenAPI, an OpenAPI schema, and then does the validation from there. But basically you start from something totally different. I mean, it's okay, but when a Go developer who's never touched Clojure comes to you and wants to add a field or nothing he just worked on for a while, he doesn't want to know about the Clojure ecosystem. He doesn't want to know how your repo works, your tooling works. Then you can get some resistance quite fast. And to be honest, it's also it has other drawbacks. So we took the decision that we wanted to start from the OpenAPI layer. I wanted the library that I wrote for that to start from an OpenAPI schema directly as the source of truth, not to have some other language on top of it with all its drawbacks or its super powerful powers to have to deal with. So like I said, we have experiences with that. When I started to look into that. I was dealing with this library called Blueprint that we have. And we extended it over the years to like support things that were added in OpenAPI over time, or to support new use cases, or to support some extra, some expressions that some features that were added in JSON Schema or OpenAPI that we didn't support. But there was always this problem of, it's a layer of layer of indirection. You have to look at documentation twice. You have to look at the documentation of JSON Schema, of OpenAPI, but also of the library that we wrote. And to be honest, it's work that could be avoided. The benefit was not much other than it's nice, it's done. So we decided, I decided, because I actually did that on my own time during a Christmas break. Let's see what we can do in a couple hours/days with Clojure, a bunch of hammocking and leveraging what's out there without having to rewrite everything. Well, actually, it's partially wrong. So I started by actually writing a fully compliant, or attempting to write a fully compliant OpenAPI validator, so JSON Schema parser and validator. There's still a branch, I think, in the repo of the library that shows that. But I mean, while it was fairly easy to get to, I would say, like 80-90% coverage of the spec, like all the little details that are a pain to deal with were taking forever to deal with. While you have the test suite to help you drive all these changes, you quickly realize that, I mean, it's quite an endeavor. And it also shows that when you're going to have to maintain that yourself, it's not going to be fun, and it's not going to be easy to justify to upper management. I have to spend a week adapting the new stuff in the spec version X because. And so I chose a different path. So the library that I wrote during this Christmas break is called Legba. It's available on GitHub. But it takes a different approach. So like I said, it's very much OpenAPI centric, but it is built on top of this library from Network NT called JSON Schema Validator. So it is, I think, by far the most popular Java library to deal with JSON Schema. It does also support OpenAPI, and it's very, very rich. So it has close to, I think, 1,000 stars. So it adopts all the latest and greatest of all the standards around OpenAPI. And if you look at some independent, I should put air quote around that, survey on the coverage. So you see here the graphs. They talk about draft 2020-12. You can see the first one. It covers 100%. It covers like all the required functionality, all the optional functionality, which is quite amazing, I have to say. But so in terms of performance, it's the fastest by far. Even like, I mean, it's not really important performance, to be honest, in that case. Most of the time when you write API services like that, we're not writing an HTTP proxy where, we're conservative. Given the context, just for the validation part, speed is good, but is not the most important thing. But I mean, in that case, it comes for free. So yeah, right. But it's not just a library. So I'll talk about Legba here, not about JSON Schema Validator. So when I wrote that library, I wanted it to be extremely simple to use, fairly opinionated. I don't like a library that have tons of options that allow you to change the behavior totally of a bunch of utilities. I like when you basically drive the user to one way and try to make it a good way. But it's also a toolkit in the sense that I do not provide only JSON schema validation or OpenAPI validation, but a bunch of other utilities around this. So why did we do that? Well, this way we give our users full control over what they can write in the OpenAPI files. Now, if we have to build a new service, they can write examples, they can write summaries, descriptions, they can describe their errors, they can, I mean, there's like, I would not say an infinite number of things they can do, but that's like, they can really go very far with the way they compose their files, and there's no limitation. They don't have to ask somebody, please write the wrapper on your library that will generate this stuff that's specified in the spec. It's really good for that. So like I said, all the features are available. Yeah, and something quite important. So the schemas are extendable. OpenAPI is extendable. You can add your own attributes. I mean, you should prefix them with X dash whatever. That's what we tend to do. But that's also really great, because very often in your schemas, you end up having a lot of metadata that's used by your service internally, but not exposed to the end user or to other services that have to consume it. And this, like, I mean, that's what we do with the other library that we have that has an hidden file as the source of truth. Also, a lot of metadata on how to deal with AAM, resource loading, and like authentication, authorization per endpoint is all encoded in these endpoints through special attributes, and you can do the same today with an OpenAPI. Yeah, it's one less layer of abstraction. And Legba is also very much ring-centric. So I wanted, as I said, to make it fairly simple to use. So the simplest form is just basically a pair of functions that we're going to see later. So when I say we adopt ring, is that there's no interceptor or things like that. It's basically handlers, middlewares, and that's it. And there are two functions mainly that you would use, I would say, in 99% of cases. They all start pretty much from the same arguments. So a schema, a pointer to a schema, a new URL, basically. And the map of a tuple of method and URL, which will map to the path in your schema, and then a ring handler. And depending on which function you call, you will either get like a similar map returned, but with all the ring handler wrapped with validation, a validation function around that validates every single location described by the spec. So we will validate the input, the headers, the output, the status codes, and all this stuff. And there's another function that returns a single handler from the same input. That handler also performs the routing. And for the routing, I mean, initially it used rated, but I just, now it uses something even simpler from Nick Tatonsky. I basically forked one of these libraries called the Clojure Simple Router, if I remember. Tweaked it a little bit to handle OpenAPI routes in a more transparent way. And it's a dependency of the Legba library nowadays. So how does it look in practice? So the function that I described before, which generates a single handler that does the routing and basically wraps every single handler with the validations for the given path, would look like that. So yeah, simple require, call this function, and from there you get a handler that you can just plug into any standard ring adapter. So that would work with Jetty, for instance. The built-in that you get with Ring Core, I think by default. And with all of these kind of things that we have. This is not only that. I mean, you can, while these two entry points, these two functions are the main, the encouraged way to use it. The library was built in a fairly composable way. I mean, there's quite a good amount of documentation on how to use it. And the API by itself that we use to generate these two functions, you can also use it yourself directly. You can build your own ways of generating handlers. You can use the middlewares directly and all the validation functions separately. You can decide to disable things or enable more things in some cases. And one of the goals of this library also, given that we're relying on JSON network NT JSON schema validator, we're gonna try to keep it in sync with the latest versions of the spec as much as we can. But not only for the OpenAPI parts, but also for the more like side problems because OpenAPI, for instance, doesn't specify how an error should look like. There is work from the same kind of group of people to specify these nowadays. There's in particular these RFC, which is, I think, the second or third in its second or third iteration now, that described how errors should look like for HTTP services, which I think is quite nice. And Legba I decided to adopt that for error shapes. So I mean validation errors, not for your own errors. So and it follows the same kind of philosophy. There's an example here, but basically there's a type which is content addressable potentially, pointer or URL or anchor that describes basically the type of error, but you can, if they say that from the spec that if the type is resolvable over the network or inside your schema, you can basically provide a schema that describes it, which is quite nice. Then title, and we can add extra fields, and we can add also errors for every single error you found during the validation phase, which can contain an arbitrary number of attributes. I think the only necessary ones here are detail and pointer, and the other ones are optionals, but they are the ones that the library that I use provides by default, and they also rely on standards. So pointer is a JSON pointer, which is also very based on the specification. The location is a JSON path formatted attribute, if I remember correctly. And the path, which is the pointer onto your schema from where the error comes from, is also based on something very much specified. The library does a few nice things for you. It will perform JSON marshalling when the JSON content type allows it. I mean, if it's just an application/JSON type request. It will do it through Jackson because that's what the validation library in Java uses. And we preserve that work. So in your handler, you will get the content already parsed. So you don't have to parse it a second time. I mean, you can, but you don't have to. And you can basically toggle that behavior. Actually, it's not forced on you. And the same for output. Because again, we're going to have to validate output through the same library. I mean, when I say output, it's a response. We preserve also the work for serialization, and we took the choice, or I took the choice not to do any automatic coercion. The library we had before was doing that. So if you are specifying a collection of keywords or a UID as a field, you would automatically convert these values to that. Also from string to numbers potentially. Even though it doesn't really make sense in my opinion, given we go from JSON to EDON, where numbers are already numbers. But for UIDs and keywords, so I have a couple arguments. For UIDs, I think it's a bad idea because given the number of bugs I had to fix over the years of things that were strings that were compared against UIDs and vice versa, I think as long as the library that's at the edge and performs the validation enforces that the format is UID format, which is what OpenID can already do out of the box, you shouldn't have to coerce anything. And if you really need a UID type, you can do it yourself inside the handlers or provide a middleware that does it, that reads the schema and does that automatically. I mean, I don't think it's a concern of that library in particular, but it should be. And when it comes to keywords, I think it's similar. I mean, it's a bit tricky to allow user inputs to be converted to keywords freely. There are like security concerns, and generally it's something I don't think it's a great idea. Even when you have like enum type values, I mean, you can still specify them as an enum in JSON schema terms, but in Clojure terms as a set of strings, and that's fine. I mean, the difference is not really that big. And again, you can use other libraries to do the coercion really if you have to. And there's also something else that we do. So by default, it's very strict. So Legba will throw an error, I will return an error if the output doesn't match the provided schema. But you can toggle that off because while it can be nice when you work on your project, when you are in production, you don't want to break what can be a valid output to your customers. because the output you wrote as a response is broken. I mean, so there's a flag to toggle this on or off. Another thing we do provide is overlays. So overlays, I hinted at them a bit before. It's something quite nice. JSON overlays basically allow you to, OpenAPI overlay, sorry. You can basically take a schema as an input and run an overlay through it, and you will basically run a bunch of actions against the schema, which can either remove or modify, update, I think, the location that the overlay matches. So here I have a very simple example where I say that all the nodes that contain an x-private attribute should be stripped out of the schema. And typically the user case I mentioned before, where you might have a schema for your public API service that contains a lot of information that's used internally by your tools or by your service, but you don't want to show to your end users, that's the perfect way to do it. And it's, again, based on a standard. So you could do it in Clojure, but you can do it with other, the same approach can be taken by other languages inside your company if that's the context why you use that. It's understandable by other languages, basically. It also does something else, is standalone JSON schema validation. So far, mostly shown that Legba can basically very much ease the way to build up an API services, but you can also have the need to validate JSON schemas independently of OpenAPI, which is quite nice. I mean, we don't do it, but you could validate JSON config files. So there are a bunch of, there's a namespace that does that leverages the same library again. So it's, very much compliant. And something I didn't mention also with that Java library is that it supports a massive amount of features. I think by default, it even ships with support for 50 languages. You can, generate OpenAPI validation languages in 50 languages. I'm not sure it's extremely useful, but it's there. It supports a lot of different dialect versions. It supports a lot of fancy features like vocabularies and meta schemas. And if you really dig into this topic, it can go quite far. And that's about it, I think. So one last thing, maybe in terms of the status, the library has been out for a while. It's still in alpha, I would say. It's still usable. It's very much usable because of the libraries it relies on, but you might encounter bugs. I got bug reports a couple of days ago that I fixed straight away. So be aware of that. We don't use it yet in production, even though we started to work on services based on that.